So let's start with no current flowing through our electromagnets, so they're just coils sitting either side of our moving piece of conductor, iron, steel, whatever. If we make our piece of conductor swing, it behaves pretty much like a simple pendulum. Now, if we put some current through the coil, so now we have a magnetic field between the pole pieces here, look what happens. Suddenly, the pendulum is damped. And this is because you have a conductor moving through a magnetic field, which means there is a rate of change of flux linkage with our conductor, which means we have an induced EMF across our conductor, which means that we have an induced current in our conductor. And as we know, that current is induced in such a way as to oppose the change causing it, in this case the motion. So the current flows in such a way as to try to stop the piece of metal moving. These are eddy currents. They're called eddy currents because they are swirling currents in the conductor, very much like eddies in a river. So we have this damping effect, and we could use this for electromagnetic braking, for example. We could have our spinning disc, and when we turn on our electromagnet, we can slow the disc down. Or we could have our disc moving in our magnetic field, and when we connect it into a circuit, the current will be induced, and we can use that current. So quite clearly, fairly significant damping there. Let's look what happens if we change from a solid pendulum to a slotted pendulum. Hopefully you can see that there's a great deal less damping here. Now, why would that be? How could we explain this lack of damping? If you consider this from the point of view of the current, you can see we have a solid piece of metal and so a small resistance relative to this, where essentially what you've done is to replace pieces of the metal with air, very large resistance. So whilst you have your induced EMF, the resistance that induced EMF is experiencing is much higher with our slotted pendulum, and so the current that flows, the eddy currents, are much smaller, and so the damping is much less. And this is the principle behind the lamination of the core of the transformer. The idea there is to reduce eddy currents, and what you have in effect is sheets of iron separated by insulator, and so whilst you have the same amount of soft iron in your core as you would have if it was solid, what you've done is to massively increase the resistance by laminating, literally separating the sheets of the iron with layers of resin so that there's an insulator between them, massively increasing the resistance so that the eddy currents that do form are much, much smaller. And so there's a great deal less loss of energy through heating of the core than there would be if it was a solid core.